Hello and welcome. I'm Ginger Bill, and today I kind of wanted to discuss something that was just announced, and this is the new experimental language, which is they're classing as the experimental success to C++, known as the Carbon language. So just show it from this little tweet here. Chandler Carruth announced it at the C++ North convention, which is held in Toronto in Canada, if I remember correctly, and here it is. So showing off the new little project that they're showing. So they've got the new images here. For instance, this is a little thing they're going on here to show some of the features. Not going to comment on the syntax as of yet. Just going to show you, yep, they got a little language they're working on, and an experimental successor to C++. So there we go. You see a picture of him and many other things. In the talk, from what I understand, they've got some other pictures here on another tweet here. They're saying that this is effectively going to be the Kotlin is to Java is to Kotlin, and C++ is going to be Carbon. That's what their goal is, at least. And okay, very interesting, at least. So they go and then there's probably some more images here as well. The full talk I don't think it's been released yet at the time of this recording, if there has been any actual talk. But it's kind of interesting as to what they're doing, and I'm interested to see where they're going further. So first off, let people know, I am the creator of the Odin programming language, so I do know a little bit about this stuff in this domain anyway. And the Odin programming language is a general purpose language that is built upon distinct typing for high performance modern systems and data-oriented programming. It is an alternative to C for the joy of programming itself. So if you want to have a check it out, you can check it at odinlang.org. And check it all out. Again, Odin is being used in production right now for Django FX's EmberGen, which is a real-time volumetric fluid simulation for games and film. So we can do smoke and fire and explosions. So you can see some of the games we're in right now, and many of our customers as well. Yes, we've got a lot of customers. And it's a very, very useful tool. But you can show that Odin is already in production and being used. So it is a proper language. It's not a toy. This is a real thing. And then the second thing is, because all these new announcements of languages, I'm kind of really happy this is the case. It's kind of like a nice little Cambrian explosion of new systems and applications languages coming out at the moment. And it's lovely that now programmers have a choice in the matter, that they can actually choose a language they need, and they aren't stuck with choosing between C, C++, and maybe Pascal if they want to be there. Like C++, like that used to be the case 20 years ago, and nowadays you've got languages such as Rust, you've got Odin, you've got Zig, you've got Nim, you've got Hare, you've got new Carbon language. There's Lookup. There's so many, literally dozens of languages out there now that people are either experimenting with, properly making with, because they are really now fed up of the C and C++ space and want an alternative. For whatever their reasons may be alternative. From what I understand from the Carbon language, from what I've been digging around, it seems to be that these are all people on the C++ committee. Many of them are from Google, at least. And they were kind of just getting very fed up with the leadership on the C++ committee, and they couldn't really decisions. I think they were trying to it was one other way or the other, and I might get this wrong. I apologize. This is kind of my first impression of the language anyway. They were trying to, what's the best way of putting it? Wanted to break some of the ABI in C++ for better for performance, or one way or the other. And they were just, I think they've just gotten fed up with everything. I thought, screw it, we're just going to go in our own way and make a successor to C++. And this becomes the Carbon language, which they have now already put onto GitHub, which is very nice to see. And you can already try it out. I've tried some things out already, and it's not a bad thing here. They're showing off some of the syntax here and some of the semantics as well in the syntax. So for instance, they have got the generics, like template stuff, but they're specifying certain requirements on it. For instance, this T type must be comparable, and it also must be movable. They're having slices in there. They've now got this more, and it's very Rust-like with a bit of maybe Go in there and a different Rust-like syntax. Still requiring semicolons, no problem, don't really care. And many other things here, so it's very interesting to see. But it is nice to see, and they've got slicing syntax, of course, got slices, and a package declaration at the top as well, which is state what package is. They're showing why they're doing it, obviously. They've now, one of the main reasons is performance matching with C++, sure, especially since this is now built on top of LLVM. Same with Odin. Odin is built on top of LLVM. By the way, I'll be comparing this to Odin quite a lot through the talk, just to because from a design perspective, I do need something to compare it to. I want to show how I came about these problems and how I came to these decisions myself. Seamless and bidirectional interoperability with C++. This is actually a very, very important thing about Carbon, because I don't think there's any other language out there really in practice, and I mean in practice, that has this, because C++ ABI is a pain. And to have C++ ABI correct, firstly, it changes from compiler to compiler. So the ABI produced by MSVC is completely different to the one produced by Clang and GCC and such. So you have to be very careful. The second problem is that to get the ABI correctly, you have to have a very similar type system for it to even work. That's one of the issues. So if you have a radically different type system, binding to it is going to be a pain unless you do the really stupid mangled name, and then even then it's going to be a little bit, that's horror, not going to work nicely. Gentle learning curve, whatever. Scalable and comparative expressibility, yeah, whatever. These are all fine. You can read it through at your own state. I'm just going to go briefly over some of the stuff because I don't want to have this discussion go for too long. I'm going to go off some of the code examples they've just shown here in these images, then go into the design document as well and talk and then compare this and contrast it with Odin. So first off, they show off this C++ code here, where they have a struct with a float as a field, and then they span, so this is a slice of circles, and they're calculating the total area of all the circles. And they've got a vector here, so dynamic array, and passing this as a implicit conversion to spam to go to the print total array and do whatever needs to be done. Okay, that's C++ code. And then here's the Carbon code. First off, you notice some differences. They're not using the standard span and standard vector anymore. They're using slice and array. These are separate data types, by the way. These are not just like renamed. They are completely different because they want to get the performance benefits. They're already defaulting, they're using class here instead of struct, and all the fields have to be prefixed with var as well. They've got these different package declarations. So this is very similar to Odin, by the way. Odin has package declarations at the top as well. Like this is package main, and this is package geometry. And then import package math. Again, same with Odin, if you can see in this little code example here, package main, then import the fumped package from the core library collection. Oops, go through to here. So in that sense, they've got some very similarities. The only difference here is they've got a little API. And from what I understand, this means that this is declaring the API, so for it not the implementation, so they have an impl keyword afterwards as well. Sorry if I'm going over this. Don't want to keep it too long, but I also want to talk about some of the interesting things about this language in general. They've gone for a very Rust-like syntax here, for the declaration syntax at least. So they have, as I would call it, qualifier focused. So you have a token or like a keyword, the name, and then the signature or var name type, and do it that way. They're defaulting to 4 in loops, but interestingly, they type it as well. They do not. They do not have, it doesn't like implicit they're going here. They have to be typed explicitly for some reason. I'm not sure why. They've gone for a Python-like printing as well, which is interesting to say. Another thing they've done here is array is dynamic by default, and they're using tuple syntax to declare it. So I'll explain what all this syntax means because in the design document they explain it. So this the curly braces, so the parentheses, are the tuple. And then inside, they've got these struct aggregate literals, which is different but the class, by the way, and how they do it there. So everything else looks the same. And now they're just showing the interoperability between the languages. So you could have a C++ header, and then you could import it under this import name, which is a very good choice, by the way. Thank you for doing import names. And then do all the rest where you need to. So they've then imported it, done it here, and then they've exported this version to here. And one interesting caveat that I'm wondering is how they're going between the two. So I bet they've already got some built-in conversion things to make things a lot of it simpler at the Carbon level to get the interface correct. And they've probably, I might be wrong, tried to keep stuff like the array and slice. Again, I'm probably wrong on this. It's my first impressions. Similar enough that they can do the conversions between like span and vector. Of course, vector has many other things in it, which not necessarily what you want. So they're the general things. They're going to talk about memory safety or why they're trying to do it and other reasons, but that's great. Let's go to their design document, which is this thing here, which is on their GitHub page. And we can read, I'm going to go read through it as we talk and just go through the top and maybe skip over certain things. I'm not the biggest fan of caring about syntax, but I do want to talk about the actual semantics and certain ideas that they're trying to get across in this language. The first of which is there's a hello world here. And interestingly, they already have to do console.print in this case. They are allowing for tuples with very basic pattern matching by the looks of it as well. But this is declaring a tuple with those names. So that's how you're doing it. We've got a while loop, got let. So they've got var and let, but no const at the moment, if I remember correctly. Var is, of course, an immutable variable. Let is an immutable variable. That's how you declare it, and you bind it at the declaration, obviously. That's fine, doing everything they do here. Okay, again, it looks fine, it looks very common, and this is very not far different from, say, something like many people like Rust or Swift at the moment. They're saying that they have strings, a UTF-8. Again, this is exactly the same as Odin. Odin has UTF-8 strings as well, and it's in fact the entire source code is in UTF-8. So you can have non-ASCII characters in your source code as well, which is wonderful for a lot of people, by the way. You may not actually realize this, but this is actually a very useful thing to have. Interestingly, they've only gone for single line comments. They're not allowed for multiple line comments, but maybe they change that in the future. Maybe they don't want to. It's up to their choice. I do like multiple line comments for certain things, especially for like documentation. Like here's a big documentation block about a certain thing. But otherwise, single line I use a default to anyway. So let's see how they go from there. They have different build modes. So they have development, performance, and hardened. And I think that's a pretty good distinctions for what they're doing. They've got development, which is where you just want to go build fast and got most of the debug information there. Performance, when they want to do it fastest and lowest memory usage, but probably safety is not the most concern. And then hardened build is when safety is the highest priority, and then we care about performance. Rust is more in the hardened build area. It seems to be the case by default, but they're not really kind of defaulting to anything at the moment. What's interesting about their primitive types now is they've gone for booleans, signed and unsigned integers, floating point types, and string types. This is very similar to Odin's stuff. Odin has some more stuff as its primitive types, such as we have quaternions and complex numbers. Very, very useful things to do in like 3D graphics or even just digital signal processing for complex numbers. We also have many endian specific types as well. So let me just get the overview open for Odin for you. And you can see some of the primitive types that we've got in here. Let me get down to it, just showing you this. So I'm just going to grep. So here's some of the basic types. We've got booleans, we've got integers, and we got to 128-bit integers as well as word size things, register size things. We have endian specific integers, which is very, very useful for file formats, by the way. We have floating point numbers, F16, F32, and F64, as well as the floating point, quaternions. We have a rune, which is a signed 32-bit integer, which represents a Unicode code point. We have two different string types, a string and a C string. We have the raw pointer type, which is a void star you'd have in C or C++, as well as the runtime type information stuff, which is type ID and NE. So there we go. I've got that all over with and done with. They're the basic types, but for this language here, they have different. So they have the Boolean type, which is interesting to say, no difference there. They have integer types. Now, because they are built on top of LLVM, they're not just allowing for just normal powers of 2, they're allowing for any arbitrary bit width size. And I think the new spec of C++, is it so C23 or something stupid like that, is considering doing this as well. They're having the arbitrary bit width. I'm personally not a fan of this because arbitrary bit width integers don't really map to anything on hardware. So they're like, okay, so if you've got I don't know, let's make this up, an i37, well, it's not big enough. You have to split that over, goes into 64-bit register, then you trim it, no problem. What's if you go to an something more than a register size? Let's go for an i231. Ooh, that's a bit weird. So would you split that over 3 registers or 4 registers or something? And then it doesn't really map well. So it's kind of an abstraction. and then you've got to rely on the compiler doing the right thing for the little thing here. What's interesting is they've got built-in things to go up from not just 128-bit integers, but to 256. And I'm not sure, personally, I've ever needed that high. Like 128-bit integers, I've added Odin because it's very useful, but not. But yeah. It's also talking about the overflow behavior for signed. Do they talk? I'll read it in a minute. It says, for development build, it's caught immediate when it's run at time. So I bet they're doing a branch every single arithmetic, which is a little bit annoying. For build, optimizers can assume that conditions don't occur. As a consequence, they do behavior that is not defined. Oh, really? Look, right. So one thing in Odin is we've been trying to get pretty much zero undefined behavior in the language itself. I have written about this before on a little tweet thread, if I can find it, don't worry. But it's because I don't think there needs to be anything such thing as undefined behavior. This is a, lack of a better word, thing that only exists in C++, C and C++ really. And because many things were undefined, but you can define everything either in the language itself, at the compiler level, or at the implementation level, or even at the tooling level, so the standard library. And there are different places where you can define things. And integer arithmetic and how it wraps is the best way, or whether it overflows and underflows, is something you could define. For Odin, we defined wrapping as the default behavior, because if you were going to make wrapping make it wrapping an error, like overflowing an error, underflowing an error, that approach does have many, many problems to it. As I said here, like if you implement it, you're going to have to do a branch on your check, or you're going to have to define like, well, we're going to assume it never happens it. And then what happens is then we're optimizing garbage. We're having garbage in goes to garbage out, which is not optimization anymore. That's one of the reasons why I really don't particularly like what's undefined behavior optimizations. They're not optimizations. You are literally optimizing garbage. And it's not optimizations. If you don't have rules to how you optimize around things, then it's not optimization, in my opinion. But let's not go into that talk. I've talked about this at length before, and it's fine. But interesting here that hard overflow does not result in undefined behavior. Instead, either the program will be aborted, or the estimate will be evaluated the incorrect results, such as 2's complement or 0. Which is interesting with this case here. So they're saying they're either going to abort, which may not be the good option, by the way, when you're doing a runtime, a really safe language. Sometimes you don't want to abort. Sometimes you just want to be able to handle that. And I wonder how they actually deal with this. Because again, how do you deal with these cases in the syntax without maybe having something that's, let's say, exception-like, but not necessarily implement. I'm not saying like unwinding the stack, but they have some way of indicating that there's been an error on this arithmetic. Or they say it's going to be incorrect result, either to 2's complement or 0. Now, personally, I would have kept this, either one of these, either have 2's complement or 0, as I think they are probably much better results. Because then they're defined that people can take that into consideration when they're designing things as well. Again, computers are not abstract things. We don't need to treat these as abstract integers most of the time. And yes, wrapping can be a bug. This is fine. But let's not get too tied and done on with this. Let's go to the other things, shall we? Integer literals. Integer literals, so decimal, hexadecimal, and binary. Interesting they're not doing octal in there. That's fine. Yes, they do underscores. Octal, I would have put an O in there. That's fine. It's a little low, but it doesn't matter. I haven't done that. The only time I need octal is when I'm dealing with Unix, like permission modes and such. That's pretty much it. But it's still useful from time to time. Underscores is exactly the same as Odin as their digit separator. So that's wonderful there. It's great. It makes it easier to read, obviously. You can, just to get the a little code snippet example out here, so make this a bit bigger so people can see it. So you can do 1, 2, 3, 4, 5, 6, 7, 8, 6, 7, 8, whatever. And then you can separate it that, or you can just get rid of them, or you could separate them into different separations depending on which country you're from and such, but whatever. It's easier to read a lot of the time, especially when you're trying to group things together and like, oh, this is a like 4 bytes, 4 bytes, 1 byte or 2 bytes, 2 bytes, whatever you're trying to do, which is wonderful. So let's move this to the side again. Floating points. I am really surprised that they've got 16 bits. Yep, great, just like Odin, but they've got 128-bit floats. I cannot name a single platform that supports 128-bit floats natively. I bet every single one of these would have to be done in software, which is not going to be fast. It isn't. But secondly, why people are going to be using it? Well, not everyone, but that's a lie. But it doesn't make any sense. Like, it doesn't map to any hardware. bfloat 16 does, which is great, and that's a great thing to add as well to a language. So I'm not complaining there. Just find it a little bit weird. But okay, whatever. Syntax literals, again, it's very basic things I'm just going over. They've got this, yep, that, and then this one. Now, interestingly, I'm just going to write it in here. So for Carbon, they're doing this, which is the C++'s thing. And I've always found this syntax bizarre because it's mixing hexadecimal with decimal. And I'm like, what? It really does confuse me. Whilst for me, the preferred approach I did in Odin was like, no, you just write the hex value that represents the bits of itself. So you could have some float constant, like so, or whatever, just put 1 in there to make it a bit better. You could write that as your float constants, and that's the bits directly into the language, rather than having to rely on this. Now, of course, you can accurately do the same thing, but to me, this is a much better representation of something when you want the precise floating point representation, and not something in decimal. And again, this extends, and notice the H we've got here. So the 0H means this is a hexadecimal float. And then we don't need the underscore, but that's just to make it separated because I was looking at it 2 bytes at a time. But yeah, this would work for a 16-byte float, obviously, or it could even go for an 8-byte float. There we go, and you can do the exact same thing. Again, we can just get rid of the underscores if we need to, no worries. But that gives you the right representation. And in my opinion, that's much more useful than this approach, and especially since this approach is cryptic to read, and I actually have to search up every time to try and understand, what does this even mean? But that's just me. I bet some people don't have any issues, but I struggle. Okay, back to the string types. I'm really interested that they're having 2 different string types. They have a string and a string view. From what I can understand, and it's not that clear yet, but I think the string type is what I would class as a string builder, as in it's not just a byte sequence, it's also something you can append to it and modify the string as you need. And then the string view is a read-only reference for it. So in Odin, we make a difference. So they have string and string view, whilst in Odin, we have strings.builder, which is a user level, but part of the core library. So this is part of, you just need to import core strings for it. And then we have string, which is the string view. Odin also has a C string, by the way, so you can make a C string if you need for C. But otherwise, these are the different conceptions they have. So I'm just going to put let's put a big comma in there just to separate it. There we go. So there are different distinctions as we're going along. Just show them off. Okay. Interesting, they've got these literals here. Odin has the backtick to make them raw, like multi-line as well. But this again is very Python-like with a triple backticks. Very nice, no problem there. Okay, it supports tuples, and you can return multiple tuples here as well, and pass in tuples as well. So tuples are a first-class data type. Now in Odin does not support tuples, but Odin supports multi-return values, and they are not denotationally semantically equivalent. Be very careful how I phrase that. You can make them work identically at the same machine code, but they are not the same thing from a thing. Odin does not have first-class tuples, and doesn't, or nor will it need to. So if I just copy and paste this bit of code block here, let's make this a little bit smaller so you can see everything. No, there we go. And let's write the equivalent of Odin, because use double, both, and then we're just going to do the exact same syntax, even the same spacings on everything. And there we go. That's the Odin equivalent. Now, this looks like it is a tuple, but it isn't. Just multi-return values, nothing special about it. This is similar to how Go does things, by the way. And that's the case. And I'm going to show off some of the different things, why this is the case, it's different. So they're showing off a tuple you can pass here. You couldn't do this in Odin. So this is not possible in Odin. The closest you're going to be able to get is you can either have to have an array of those two values, which is probably better, or you'd have to have a struct with those values in. But in case, let's just do an array, because it's probably the closer analogy to it. There we go. Yeah, wonderful. Fine, no different problems here, but yeah, Odin doesn't support tuples, but that's fine. But it has multiple return values, and I'm explaining the power of multiple return values in a bit because they are very different to tuples. Interestingly, they have struct types, but their struct types seem to be only possible through struct literals, which have this semantic syntax. So this is how you define a struct literal. Yes, struct type, which is a bit weird in my opinion. It's kind of like a tuple, but with curly braces, and the fields have to be named and prefixed with a dot. And then you have to initialize it with the equals. So fine, that's okay in my opinion. I don't really see much of an issue, but it's a bit weird in my opinion. That it's kind of very anonymous. There's no named aspect to a struct, but I guess that's because their class structure is the named thing instead. Pointer types, they're written as T star, interestingly, so very C++ like in this case. So pretty much same semantics C++. They assume that all pointers are also non-null, so they've actually merged the concept of a reference with a pointer. Well done is all I'm going to say. But they represent a pointer that may not refer to a valid object. Use the optional T star. Like, yeah, okay, great, that's fine. Odin has both. Let's do the equivalent for this. The semantics are ever so slightly different here. So for Carbon, we have this and optional T star. And then for Odin, we have pointer to T, and you can have a maybe T if you wanted. The difference is in Odin, pointers can be null. There's no nil, as we would call it. So they have, I'm guessing, null, and we have nil, just because, why not? Just a name, isn't it? These assume to be non-null. Odin's can be nil, but if you want to explicitly state this is the case. I've stated this before, but I personally don't think that null pointers are $1 billion mistake, personally, or at least not as bad as one. The main reason is that null pointers are just a class of invalid memory addresses, which are empirically and also technically easy to catch. They are a big class, like for instance, null is just, well, okay, we assume null is the invalid value, and then we can easily check for that one. So how do you check for the other invalid states? It's like, that's not as easy. But also empirically, it's very easy. So when you're doing loads of testing, obviously, the first page, or even probably pages in general, especially 64K bytes of virtual memory space is reserved, and you cannot write to it or read from it. So this is very easy to test for, and most invalid things, I would say, result in that case. And the more complicated ones are because of some corrupted data, and they're really hard to find sometimes, those are. And I find that the ones that are a problem are more to do in the corrupted space when you've dealt in weird C++ code bases. I'm not saying this is in Odin. I've never had this issue in Odin. It's in C++ or C because of its stupid type system. That's when you get these really weird invalid pointers. But both Carbon and Odin will not have these problems by the sounds of it because they've got both the slices and also better safety features built in. That's great. Arrays and slices. It looks like that Carbon has completely wholesale copied the syntax for arrays from Rust. So this is Rust-like syntax for an array, and Odin's is, that. So it's a very Pascalian approach to doing things, which is what Odin's trying to do. And Odin's got a very simple rule. It's like the type's on the left, the usage is on the right. So if you want to use this array, all you need to do is use it. Like, look, it's the same thing. And if I want to do a pointer to a thing, I can go, oh, use it, then dereference it if I need to, or whatever. And there's this lovely symmetry between the two of them. And notice that you can see it's the copy, it's the same kind of semantics. Like this could have been another array, and like, oh, we can just put another thing in there for us, no problem. And because of many of the automatic dereference semantics in Odin, you can just get rid of that as well. But you can be very explicit if you want it. But notice it's just easier to read. While compared to something like this, how do I do it? So let's just keep these the same for the time being, for demonstration purposes. The next thing is the showing how they do literals. So if I do this, in Odin, the equivalent would be 1. And then I'm going to write and I'm just going to write the literal, I32, I. And this is how we're doing it. So we could write the type explicitly in there, or we could just put the question mark, which is dependent on here. If we get rid of the question mark in Odin, this is a slice. And if we put the keyword dynamic in there, now it's a dynamic array. And you have some massive benefits already from this syntax, but you can see they've tried to go the Rust approach, and also they've merged these their array literal syntax with tuple syntax. So they've got some nice little unification there. But Odin's gone like all compound literals are like this. You got a type, or an implicitly a type, along with the curly braces and the fields. And in fact, in Odin, which I don't think is possible with this language, is you could have the fields be labeled like this. You could have them. It could be in any order, by the way. So this could be 2, that could be 0. Or if you really, really wanted, you could say, oh, ... 2 equals I. You say you just do a big range between 0 and 2, there's I, and then you're set. So you can do ranges, which I don't think is even possible with their syntax as standing, because it's very tuple based. But because you can do this in Odin, because it's unified in that syntax case, you can do some lovely things, which was only available in, like, say, GNU-C, which is where I got the idea from, and it's also one of my favorite kind of like little things in the language. Sometimes you can do this. Like I could even do 157 equals I, and then I could do the rest after this if I wanted. So 2 to 157 equals, I know, 123 if you wanted, and you could just do that, and then this will go, oh, this is 157 here, it needs to be fit in there. Thank you, compiler, because it's simple. But yeah, Odin is a lot cleverer in many cases, and I'm just going to write it all out, all of the different cases you could do, and there we go. Wonderful, right? Okay, expressions, they're fine. They've got the tuple structs. This is all seen. Arithmetic, fine by here. Interestingly, they're now using the caret for bitwise not, so they've taken directly from Go. Odin does the opposite, by the way, so it goes in the opposite direction. So let's say you've got this, and then not, what do they use as their example? Not 7. Yeah? Odin has gone in a completely different, well, not completely different direction, but a different direction in general. It has done this. It's gone 3. That is its not operator. That is bitwise operator. And it also has an and not in there as well, which is a specialized operator. Because then you can have all these be, oh, x XOR 7. That's fine. Odin also has the ability to do this. So x XOR 7. But it also has the ability to do x and not 7. So you can do these benefits, and it makes it simpler and much easier to deal with. So let's just put some types on here to make this a little bit clearer what's going on. But yeah, like notting, what actually are you notting? Not just some random thing, which is nice to know. They've got all the other syntaxes fine in here, and that's fine. I'd love to know what bit shifts are, but I bet bit shifts are going to be designed in the exact same way as C++. They're undefined if you over or under go, but I'd have to completely read the document properly, because, like for instance, if it overshifts here, things, yeah, they have big, extremely large numbers, which is fine. But if you do that in Odin and you overshift, it will just go no, don't bother. Yep, that's fine. I'm not going to go over that yet. Let's go over it. So the last thing they've got to talk about is they've got move semantics, which they haven't really talked about much yet, but they've got move semantics, and I've just accidentally went past it. Yeah, and they're using the tilde operator, which is why they didn't use that for not, to do the move semantics. Okay, fine. Right, no. Now, I'm not criticizing or praising that or anything like that. Odin doesn't have move semantics because the main reason, loads of reasons why I'm not a big fan of them. They enforce a certain style of programming that may not be what you want at all, especially with linear types, or technically they're affine types, but whatever, and with the substructural type system. And the other main reason is that I use a lot of custom allocators everywhere, and ownership and lifetime is not as easy to define in the type system as it is to define in other subsystems within your own program. Yeah. So that should be absolutely fine. Patterns, okay, they've got basic pattern matching and binding patterns you can do, which is part of the whole reason having tuples, I'm guessing, as well. Like, oh, you have auto thing has a tuple of a tuple inside of it, and you can nest it out and get all the stuff that you need. Okay, great. And they're using auto in here, which is interesting because it looks like every declaration must have a type on it, which I would have thought, why can't you have basic inference? Effectively, if you don't put the colon there, assume that it's going to be auto. That's what I would have thought I was going to be doing. But maybe they want to keep it very C++-like with explicit typing. But trust me, from a design perspective, have automatic types. So for instance, in Odin, let's do the equivalent of this. You can't do this, by the way. You can't have a nested tuple, but let's say you were. I'm just going to try and do the equivalent. It doesn't really make any sense. 43. So let's say you got bar, proc, it returns an I32 and an array of F32s, whatever, and then foo proc here. Is that nice? They've got an implicit conversion here. So what you would have to do here is you got p and then blank in Odin. You're going to declare it as var bar. And then what it also Odin makes it really specifically clear here, you're going to have to do an explicit conversion when you didn't have to do it in Rust. Because notice here they've got an I32 as an I64 here, and they've declared as an I64, and they've done an implicit conversion. Whilst in Odin we've gone like, no, you need the explicit conversion. Because that's what's happening. What type of widening are you doing? And also Odin has very distinct types. So a good example of this is I could make a distinct my fav. That's what's got my fav, and this is going to be a distinct I64. I can't even spell today. So this is not the same as doing I64. For instance, even if we had an I64 and we couldn't return this X from it because they are distinct types, you'd have to do the explicit cast to go between them. So this is one of those where I'm not a big fan of the implicit conversions when there's stuff like this, especially. But the thing is, in Odin, you're not doing many conversions like this in general because of how expressive the type system is, and also how the constants work. You'd be surprised how much explicit conversions you need to do in the first place. It's not as needed as much as you think. So this is kind of nice. So how it's gone like this. So let's move this back to the side again. Refutable patterns, whatever, main binding. Okay, whoops, shouldn't have got clicked on that. Binding patterns. They've got constant let declarations. We already saw these before. It's lovely. Auto, which is their type in there. I'm like, you could just get rid. I don't understand why they have to be explicit about this. Couldn't they just syntactically make it so it's auto by default? I'm not sure why they're doing that, but whatever. Procedures, yep, very similar. You can see the order distinction, the difference in Odin. They're returning auto. Now, Odin does not allow this. We do not allow you to infer the return type from the return statement. And the big reason from this is because this now means that you've now got to evaluate the body of that procedure there and then, rather than having ability to defer it or have it out of order. You've got some now really weird semantics, because I'm not actually sure if this language is in order evaluated or out of order evaluated, or anything else in between. Like it might be in some places in order and then some places it's out of order, and it's like, I'm not sure about this. And also in general, you don't really usually want auto. You want to be able to read it and go, oh, it returns bool. The auto stuff, especially when you're doing like the decal type auto stuff in like C++, is weird to say the least. It's trying to get around a lot of the templates malarkey, which I'm not particularly thinking is a good idea in the first place. If you've got yourself into that mess, you probably shouldn't do. Or another way they may be thinking is autos make it more like a functional language, which, not functional language, a more of a interpreted, dynamically typed language. In a sense, not just dynamically typed language. What am I talking about? I'm saying words coming out of my mouth. But I'm not sure that's necessarily a good idea. Block statement's fine. There's no difference between Odin. The only difference in Odin is if I write this, so just copy and paste this while loop. One benefit about Odin is just let's make sure that's there. The thing about you could do in Odin is that this equivalent, you get rid of the braces, and a while loop in Odin is called a for loop. So Odin takes kind of a similar approach to Go in this case, where it only has one loop, which is the for loop. And that's done on purpose, mainly because I only wanted one for loop construct. I didn't need... I also am so used to in C of actually doing this. Like there's an infinite loop, and I sometimes even in C do this because it's very common. Sometimes I need to add an initializer or a post thing in general, which if I need stuff. But luckily, and I think both languages support this, judging by what the syntax was already, this would have been the for in loop in here. And oops. And in Odin, the for in loop looks like this. It's got rid of the parentheses, and it's got rid of the need for you to have a specific type declaration. Just it infers it from the array. And I'm not sure how they are going to do an index, but in Odin you can literally just put I to put whatever the index was in there if necessary. So you've got both this and this. So you can always do this as well. And this also works for slices, arrays, SOA data types. So these are structure of array types as well. It works for maps, many other, and strings as well. So it's kind of much better kind of a feature set in Odin. I'm not sure how they do the offset. There might be, or they might require you to put an iterator in there that gives you a tuple of the values. I'm not sure yet because it's not that easy to see with their syntax. Control flow, curly braces, yep, similar to Odin. Curly braces everywhere. Loops, they've got a while loop. They've got a for loop, which is a for in loop. We could always look at their for in loops to see if see what their proposal is. Do they allow... Nope, I can't really see it in that quickly enough. But yeah, I've got break statements, yep, continue. That's fine. So return statements, no problem here so far. Just it's a return statement, it's like anything else. Now the crazy thing starts coming. They have this returned var. And I'm just going to copy and paste this and trying to explain the behavior of it whilst also writing the Odin equivalent. And I'm going to write the Odin equivalent first and foremost. So radius I32, circle, let's see, radius, return. So what's happening here is in the Rust side, they are having a, okay, we're going to have the variable that can only be used as the return value. And they're saying returned, and it's this variable here, and they're writing in the body. So then you can use this as a normal variable, but when you do return on this, you have to make sure you do return var. You couldn't do return C, because that would be invalid or something like that. So this means you have to do return the returned var. So this thing, you have to return the var. Firstly, that's just a little bit weird. The way that Odin does it is it just directly names the return value, which is also really good for documentation purposes, by the way. So when you also have multiple return values, you could just name them if you needed. This named return value is a variable. You can act just like a normal variable, assign to it, and then just return with a bare return. Now, you could write return C if you wanted in there, or return anything else, but it's very common just to do a bare return and you didn't need it. So this entire thing, my minor improvement to this, but I don't think it's possible with their syntax, by the way, is they could have done this and they would have solved their problem. Now, I don't think this is possible in their syntax because this has to be a normal type. So it would have to be, I don't think they could have named parameters yet in their syntax. So it's just their syntax is already restricting what semantics are possible, while Odin's more like, yeah, we can do whatever we want. And we can make this really, really simple. In fact, we can even have default values in the return values if we wanted. There's no reason why not. It's just a field. And it's very nice to do. So Odin's, in my opinion, is a lot more cleaner, a lot saner, and a lot more flexible than this approach, which is in the body. So when you're reading the documentation, you don't have the luxury of naming a return values, which is like an auto documentation. Like this thing could also mean not just make a circle, but this could have been like the we could name it something though. This is Bob's circle, which may be really, really important in documentation, maybe. But there's the case, and there's the difference between those two. They have a match, which is similar to a switch, and their match has all of this different pattern matching going on. Now, Odin doesn't have pattern matching because it doesn't have tuples, nor does it have ML-like unions, but it does have discriminated unions there. I'll explain in a minute. But like, this isn't even possible in Odin because it doesn't have pattern matching, because it doesn't need it, which is kind of a little bit, wait, what? And it's like, we'll explain in a bit. It doesn't have tuples, it's fine. And it doesn't have ML style units, so it doesn't make any sense in Odin. But that's fine. Not every language needs it, obviously. Luckily, it's one thing they've done here is they have no need for a break. Everything seems to be broken up by default. But by default, this looks like no, it's fine. Yeah, it's just a statement. It looks like it's just a statement. Does it work as an expression? Doesn't state. I don't know yet. It might just be a statement. If so, that's fine. Odin's just a statement as well. But this would allow for it. I don't know. Classes, okay, this is interesting. So Odin has no classes in it or methods. It's just structs, plain old data types, because it is an alternative to C, not alternative to C++. So the Odin equivalent would be widget struct x, say xy i32 payload string. So the very big distinction here. So this is a class declaration, so it's already doing this, and they're prefixing it with var, so this is very Swift-like. So these are variables in here. I don't think this is to make any sense in their syntax, yeah. But Odin's like, look, structs, they only contain fields, that's it, that's all we can do. No methods, nothing fancy. And this is just a constant declaration, so this is a widget, and we're declaring it, and there's an implicit, technically you could always put the type ID in there. It's a type, but whatever. And then struct in there. But yeah, this is the way you'd see it. We've got an X and Y, which they can share a field. I don't know if it's possible to do that in there, but I doubt it is because it doesn't have multiple return values. So I don't think it would work with their syntax. And then they have a payload, and then you got payload, it's fine, whatever. And we'll line it up there to make it simpler. So it's very different. Notice these are also semicolon terminated. In Odin, they're comma terminated. This is on purpose in Odin. It's because I did want this just to be a list of fields. You cannot embed any other declarations within here. But this looks like a class is containing type declarations, which we'll see in a bit. Here we go. So it's fine there. So you can have the assignment, which they're using their struct literal assignment to do it. That's fine, whatever. And there's a bit of inference going on here, which is nice. Same with Odin, you can do the inference. For Odin, this code is going to be, I'm just going to copy and paste it to make it simpler. You can do this if you wanted, but what I'm going to do here is I'm just going to get rid of this here, and I'm going to make this the same, by the way, just to make it the same. You can either do this line, or you can just explicitly type it and then do inference on there. So you've got the same things here. Notice none of the types in Odin have to be prefixed with a dot either. The dot stuff comes from C, and see, where assignment is also an expression. So to get rid of the ambiguity, you have to put prefix with a dot, which is fine. But I'm like, why have they kept to that? This is my question. Or is it because they wanted so they can have it copy and paste C++ code in and still work? Which doesn't make any sense in my opinion. So why? Just things. I'm a bit questioning that. But that's syntax. They can change it. I'm more worried about the actual semantics at times. They have methods and such in here. Now, I don't have methods in Odin because I didn't want methods. I think they were a rabbit hole of a feature because if you start going down the method route, you have to do all these extra things on top, which they've tried to do. They're getting there, but they're not fully done because they're trying to be compatible with C++, so they can't diverge too much to make it in the way they would want. But there we go. Fine. You've got a little method, which look, it's just a big list of declarations in there. That's why the semicolons, and they had to be varred. Class register. This is a create. Looks like they don't have. Do they have constructors? Does not have separate constructors. Is that good? Oh, that's interesting. So it looks like they do not have RAII. Probably. Let me just doubly check quickly. I'm going to just click that so we can get. Yeah, so we can get back to it. I'm just going to type in RAI destructor. Destructors. Do they have destructors? Yes, they do. Okay, that's fine. So they have no explicit constructors, implicit constructors, but they have implicit destructors. Okay. Methods. One thing that's interesting here, this is very similar to Go in some ways. I mean. So I'm going to just show you what they've written. I'm going to delete it straight after because there's no Odin equivalent. But this is, and I'm just going to do another one here. So this is Go now. They've got a point. So in Go, you would go type struct x, y, i32, like so. And then you would have to define your functions separately, your methods separately, which is what this thing is doing here. They pre-declare it. They have to, for some reason, pre-declare it. And then you can define it elsewhere. But yeah, I'm going to define distance first. So this is going to be me, point, and then they've got called it distance, x2, xy. There's no colons anywhere. What am I doing? This is Go. And there's no such thing as that, is there? No, it's int 32. Whew, it's hard to just do it. And then it returns a float 32. Dx dy is going to be, and you can do the curly braces, we can do the var syntax. Let's use var to make it a little bit closer. X2 minus me x, and then y2 minus me y, and then we could do the math dot square root of dx minus dy dy. Interestingly, that's how they're doing distance. Interesting. I would have thought that's a plus, but whatever. That seems like it's a typo, but we'll just copy the code. And then the next thing here is for an offset, and this is why I said it's very similar. They're doing address here, so they're saying this has to be a pointer to, and they're saying take the address of it. In Go, you just do a point thing there, and then dx dy, it doesn't return anything, and then you can just do me.x plus minus dy y. So that would be the Go equivalent of this code. And I personally prefer the Go approach because this means you can apply methods to any data type, not just structs or classes or whatever, because of Go's type system, how that works. But also I think it's clearer to read because here's the struct, and then here is the stuff. Now technically we'd have to make this capital X and Y in Go to make sure this is public. Because one thing that Carbon, I think, has personally done correctly is everything is public by default, not private. Now, many people disagree with this decision, but like, no, public by default is the more practical approach for doing things. So if you're ever dealt with massive code bases or ever tried to deal with someone else's library, if it's gone private by default, but you as the programmer actually needed that private behavior, it's a pain in the ass to just try and get it out. Because it's like, oh, how do we get this out? It's like, you can't unless you copy the headers and it will modify them in place, and then you've just done something really hacky. And it's like, if you just did private by default and public by default, and private in very specific cases, it solves a lot of issues. Now, Odin does not have private fields. All fields are public on structs in Odin, but you can have private declarations to a package. So my personal view is that the private-public distinction is better suited at the package level, not at the type level. And this is a better way of solving this problem because I think most of the things that many people use objects for, or give the arguments for at least, like encapsulation or private, public, private, whatever, the same thing as you know what I mean. Those arguments apply better to the package level, to the library level, module level, whatever to call it, than the type level. And that is sometimes because people are used to using these languages with classes and they don't really have package systems to them at all. And that's why they're used to it. They don't really know any alternatives. But let's go back again, shall we? There's inheritance in this language. Again, I think many people say, well, you should prefer composition over inheritance, whatever that, just care what about the mantra is. But I think they've kept within inheritance here is mainly for mix-ins, and as well as keeping it same with C++. Because C++ uses inheritance, it does not use you can do composition, but it's not built in. It's not like Go, where this interface system you could do, or Rust trait system. It's a type class system. For instance, in Go, you could do type. Let's call this an distance, because that's the convention people usually use. I'm going to copy and paste that in. Plop, 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 and then that's what that thing. So if any type that has a method which has distance on it means it now fulfills this distance specification. Whilst if you're using inheritance, everything would have to explicitly inherit from this, and then you'd have to make sure you've got very small things that you're doing up, and it gets a pain, and also the memory layout's not always going to be nice as well, but that's different things entirely. Different considerations, obviously. They're just doing the abstract base class and then inheriting from it, fine. Access control, they have private, protected, and friend still. No. They shouldn't have been protected or friend anywhere, in my opinion. You should just have public and private. Or the better option is you should just have private, but it's private to that package, like Go does. This is a much better way of dealing with things, because then you've got rid of the need for a friend type in begin with. You just have private to that package, not private to things using that package. That solves your need. You don't need friends, you don't need protected, but maybe they're doing it because of how they interact with C++. And maybe they need that. I don't know. This is half the problem, but when you're trying to interact with C++. Destructors. You have to use a destructor keyword, and then you specify it and then do that. Sometimes you can modify it as well. Odin doesn't have destructors in it. In fact, everything's just plain old data. Everything's a plain old data type. That's the whole point. It's very C-like in that regard. But Odin does have the defer keyword. So they're using destructors. So I'm just going to copy and paste this. I'm just going to go trying to make this very clever. Oh, not very clever, but you know what I mean. I'm just func. Let's make this 8. Not my 8. Make it 4 for you guys because it's getting a bit big. Sorry, I'm used to 8. Yes, I'm one of those weirdos. Create, and I'm guessing it's my class. Whatever. There might not actually been the syntax anymore. I don't know. I'm just going to make up syntax. I apologize, people who are now using this language, and they're looking back in the past like, hey, this is my first impressions. Whatever. I'm just going to put ... in there. For Odin, you would just have, let's call it my class as well, even though it's not a class. Struct, whatever here. And then you'd have your own functions. So you may have my class make or init or whatever. So let's make it an init, just to make it simpler. And then I usually have a destroy in there as well. And then when you're doing this, M for my class init, and to make sure you've got the destructor form, you can just do defer. Oops, sorry, destroy. And defer it. Sometimes this doesn't even need that. You could probably just have init and destroy in there, and there's no real need for it. But there's a nice kind of benefit to this system. And this is extendable as well. Because everything is just basic plain old data, there's no worry about having to do destructors or anything like this. One issue about this system is I'm worried about how does it copy? Does it just do a plain old copy, or do you have to have a copy constructor going in there? Or maybe anything that has a destructor must have move semantics associated with it or something like that. I'm not sure how this is going to work. It's probably a little bit, or is there an implicit destructor if any of the fields have destructors to them, obviously? Are they going the full C++ route, or are they keeping it simpler? I don't know. This is half the problem when you're trying to effectively build on top of C++. You also inherit loads of its cruft and loads of its issues. When you're something like Odin, which is not doing that, it's going in a completely different direction and going look, We do not want to do the same issues as C++. That means we're not going to keep its cruft. Same with thing. We're not going to keep any of C's cruft if we can help it. Because C has many issues at the type system level. And I'm not just talking about the syntax. I'm just talking about the type system as well. It's kind of broken. Like loads of places where it would have been better off designed, but it wasn't in that case. So we have this here. We're going down. We have, it says const. There's no design for const yet. So const in this case seems to be a const on the type itself. So a qualifier rather than anything special. Like, okay, fine. Odin doesn't have const, but it doesn't really need it. The thing is that most of the time when you have const, I've found in C++, there are pretty much only two reasons why you really want to use const. No, three reasons, sorry. Three reasons why you use const, in C++ at least. The first one is where you're doing static int const, something like this, and you're doing a constant in a global thing, or even array, and you're doing whatever. That's the first time. Now, I know people say, you do const on the east and not on the west. I'm like, yes, I do. Whatever, I don't care. That's one version. The second reason why they use it is for strings, constant strings, because most of the time you really want constant strings. If you've got a char star, you're building the string still, and then once you've built the string, it becomes constant. It's very rare you'll never pretty much ever mutate a string unless you're doing something very hacky, and you probably shouldn't have done that. When you're building up the string, this is my distinction anyway, building up the string, it's not really a string yet. And then when you've done it, you pass it as a constant. And then the last one is to indicate this is an input parameter into function. So like, let's say we have void foo, and then what we're doing here is t const x. What we're saying to x is if we got rid of this, we're saying that x is an input parameter. And we were doing that, we're also giving it an optimization with the const there, but we're saying it's an input parameter. We could even say this for a pointer. So we could say p const star y. If we have the const there, this is saying that this is an input. This would be an output, or an input in-out value. It's very hard to tell in this, but it's an input or an in-out value at least for that. So the const tells you it's an input. They're the three main reasons most people use const, I would argue, in practice. Now, some people say, no, I use it also to make sure I don't mutate certain values. I'm like, that's probably true. But I find in practice that they are the only reasons why I would use const as well. And when I come to use Odin, and I'm just going to go to the same number so people can read it easily, we've got the same thing. So constants, actual constants in Odin are compile time known. This is probably equivalent, well, not equivalent, but it's closer to, say, a define than a this static const, and that's fine. Arrays, you most likely don't want them to be used. And also, one interesting thing about constants in Odin, they're untyped, meaning this can coerce to anything that can be represented by. That could be any int, that could be a float, by the way, that could be a complex number, that could be anything that can be represented by it. Any distinctly typed integer as well, float, whatever. Because it's untyped in this case. It's a very useful pattern. Variables in this, you can do some optimizations to make this get in the right data sections. It's not a problem. That's what the static bit's kind of doing, really. Static const bit. In Odin, we have string. This is internally, if we do in C speak, this is a char const text followed by a size and score t. That's not a real of the length. That's what that is. And this is very, very useful. And then the Odin equivalent for the latter here would be foo, x, t, and then the y one you very rarely need. If that is just an input, you may be passing that by pointer, but it's probably likely you're passing that by value anyway, because it's just by pointer. But if you need a pointer, that's fine. Now, one benefit you think like, oh, isn't this going to be an issue? And the answer is kind of not, because in Odin, parameters are immutable in Odin. So by default, they're already immutable. So you can do some beautiful optimizations if using the default calling convention, that this can be passed as const reference if needed to be. And then this is effectively if I had a const here, which there isn't such thing in Odin, by the way, there. So it's kind of a nice little thing. But another thing you can have is if this was a non-constant parameter, it's probably more likely you wanted this as a return value to have multiple returns. So you didn't even need to pass it by pointer. You just return the value and do it correctly. Like you may have had multiple of these, like PZ. And it's like, oh, that's the way I get multiple return values. It's like, yeah, we just return 2 values from Odin. That's one of the big reasons for multiple return values in Odin, is because it is very common. You want to pass multiple things by pointer, which are only output variables. But really, you just return them in Odin. Really quite simple. And it's really nice as well. That's quite nice. I'm rambling. This has already got an hour now for this talk, so I said I didn't want to keep this long. But yeah, so they've got move semantics in here. They've got a choice. I'm just going to quickly brief over here as well. Go over here. The Odin equivalent to this would not be this. It's actually a little bit weirder than this. So the way I would do this in Odin is success type is going to be distinct 32. Failure is going to be string, and make that distinct as well. And do this. So this is going to be a little bit weirder than thing. So Odin's union for C++ programmers out there, by the way, is probably closer to like standard variant in C++. A lot closer to it, in fact. Not exactly the same, because it's got much better semantics, much better everything, to be honest with you. But it takes in types rather than having names and then their fields. So this is very ML-like. Interesting they called it choice. Don't really care why, but yeah. But notice they're having to do all the fields separately here in this. While in Odin, they're just like, no. Notice I also didn't write cancelled, because in Odin, I would keep this as the nil value. Because the default nil value in this case would be cancelled. There is no success to it, nothing like that. The other benefit that they have in here, let's do this. Let's do this here. The Odin equivalent would be pass as int. I'm just going to keep it the same. Keep the same. Get anything on here. Success, failure, and the default. I'm just going to return that value. So we can just call it value, shall we? Return, let's say display value, and then we're going to say terminate, because if it's the nil case, we could always put whatever, we just do that. That's one thing. But Odin's thing here also applies to enums in general. So I think their choice is probably also, do they unify that with an enum? Do I see enum in here? Yes, so they've done the unification thing. This is very popular in like ML languages, like even like Rust as well. But in Odin, we separate it out. So we have like a Boolean enum false true. Now, I'm not sure how they specify the size of that enum or anything. In Odin, we could go, oh, this is a U8, this is an I32, this is a U64 big endian type if we wanted. We could also set this to be 1 and that to be 0 if we wanted. And we could set those values. I'm not sure how they're doing it yet in their language. Another benefit about the Odin thing is if this is a switching on it, so let's say we're just going to have some thing in there, and notice we can declare a little prefix like type in here. I don't think that's possible in here. Maybe it is if they do var x. Like they have to do auto in there as well, and then you do x. I doubt that's possible in their syntax yet, but it might be. In Odin, we can just do this. We can say false true, and then we've got all the cases handled. And in Odin, it will yell at you if you do not handle all the cases by default. That's wonderful. Same with the unions as well. If you do not handle all the cases by default, it will yell at you. Which is, again, very nice. Many people say these are not kind of equivalent. Like this one's got labels to it. And I'm like, I know, but I'm doing it because of Odin's distinct type system. It does actually allow for a lot more flexibility and a lot more benefit from this approach. And you'll probably find it much nicer to use in general, because that's what you want. Like a lot of the time, you're just going to name things and then wrap another thing on top of it. So you actually, it's just a bit more noisy. Whilst in the, let's just put this as 1 and that's 0. But yeah, you could do whatever you want to here. That's fine. And we go unknown and we go 2. And then it will complain at you, you haven't done this. And notice what I've done here is you could do like a Boolean, but because of the type inference system in Odin, you can just write dot and it will do it. And it's wonderful. Same in here, I'm guessing. This is, you could probably just write int result dot like that, maybe. There you go. Absolutely fine, isn't it? So that's that. There are more things to talk in here, obviously. They've got the package declaration stuff, which I think is a little bit weird, especially with how you have to define. There's loads of extra things in here, like okay, and how the package scope stuff, like API and the impl stuff, which is a bit weird. I'm not sure why they're making that distinction there when you don't need to if you're designing a new language. Maybe you do, maybe in C++ with headers, but you don't need headers anymore. I don't know what they're doing. They have namespaces still. Why? You've got packages. You don't need it. And also, maybe you do need it because you're implementing C++ again. Oh, damn it. But you don't need it in your language. It's not needed. You've got packages. That solves pretty much every single need you need. Gone. Keep it flat. You don't need massive hierarchies of everything. This is not fine. Naming conventions, they're just idiomatic. They're not, thank goodness they're not in part of the language. Aliases, fine. Odin does that really easily. Let's just copy and show it really quick for Odin. We're not even on the right number anymore. There we go. An alias in Odin. New name. Some package dot old name. There you go, done. It's just a constant declaration. Look, you can put all the spaces in there you want, but whatever. That's an alias in Odin. It's wonderful. Like, that's how you can do it. And then you can export that from your stuff, no problem. Aliases, they've got aliases within classes. We don't do that in Odin. Extern, so external implementation as printable. So I think this is to do with their like trait name type class system or whatever. The name lookup resolution stuff. Oh god, this is insane. You shouldn't needed it, but I know why they've done it. But no, just don't. Again, this is also weird. Like I find this weird. You're pre-declaring the type, the methods, and then you're implementing them. Like, why couldn't you just don't need to pre-declare them? You could just do it as you need to do it, as long as it's within the same package or even the same file. Maybe probably package, but yeah, like Go, just copy Go's approach, much cleaner approach. Now it comes to the generics. We're nearing the end now. I apologize for this 1 hour and 10-minute long video. Yeah, okay, so one interesting thing they have here is the generics thing. So they have this square brackets. This is very similar to the new Go approach, by the way. I'm just saying, keep your thing. GNO's generics and stuff. So they say, look, have a parameter T, and it must be ordered, is what you're saying. And if it's not ordered, you can't do anything with it. So I'm going to write this out. I'm going to show you the differences that you could do in Odin. So firstly, this is their built-in min. Odin has a built-in min, by the way, and you can have as many parameters as you want in Odin's built-in. Odin has min, max, and clamp built into the language itself. So this would work correctly as you expect with as many parameters as you want, not just 2. And it's built in because then it works with the constant system and many other reasons and many other nice language features as well. But let's implement the one they have here, shall we? In Odin and the equivalent. So x, y, $t, return t, and then there's an intrinsics, but I'm just not going to write it. Say type is ordered. Just to keep this simpler, I'm just going to keep it like that. I'm going to probably put the where on another line just to make it easier to read. Return. Now I'm just going to do it the Odin way. If x is less than y, else y. So what this is, these are very similar. This is very close to the Odin approach. So this is saying have t, make sure it's ordered, and then you can do whatever you want with it here. Odin doesn't pre-declare the type here. It does it in line with the dollar symbol. It says, look, this is a paramorphic type they have to determine, and you have to do it there, and then you return t. We're also restricting t must be ordered, so type is ordered. So it's a function, it's a procedure call rather than a trait system. I'm going to say traits just to keep it with Rust folk. And then you're doing the if statement. So Odin's is not like this. So this is very if x then y else if then x else y. Here's more like a Python approach. We're doing x if this is true else y. You can also, for legacy reasons, this is just like C legacy reasons, you could always write it like this if you wanted, like C, like it's not stopping you, but we usually prefer you to use like the Python approach like that, because it also works for Odin's compile time if statements, which are called when statements. So this would have to be compile timely known, which I don't know if they can do that with their expressions. Maybe they have to have a const expression thing in there. I don't know how they're going to do it, but probably that's how they're doing it. But yeah, that shows you the differences. So notice Odin has this where thing, which is kind of similar to Rust in that regard. You do it afterwards rather than before, and you can define these in line, which is actually really nice, because you could always have this be have loads of stuff in there embedded, and say this is also a specialization of something as well. Like this is specialized. So yeah, it's like, oh, this is an array of unknown size of unknown t, but the t must be a specialization of foo, whatever. This is probably complicated. It's not. Generics gets really complicated really quickly in any language, so I'll digress. T must be a checked parameter and compile time, while if you don't have it, it gets checked about the body, which is probably interesting. And T is also a template in here, so you have a type. Interesting. Yeah, sure. Whatever. Yeah, Odin has the same there, pretty much, no different, just different syntax. Okay, now it gets the interfaces. Thank goodness they have interfaces rather than just inheritance. And I bet this is static dispatch, not dynamic. But interesting, they do this. So they even specify that it must be passed by value and not passed by reference or pointer, which is interesting. And then you have to be explicit when you implement it, which I don't particularly like myself. I prefer the implicit distinction, like especially in Go. Because even if you do static dispatch and do it implicitly means that a library which didn't have that implementation can be used by something else later on, already just by virtue of having that method. That is such a really nice flexibility. It also keeps your interfaces really, really small. Whilst interfaces, when you do this, you have to be explicit, they do have a tendency to get quite big. Compared to languages which have very small ones to them. But that's just a thing about what humans do in general when they do things. If you keep them implicit, they actually tend to be small. As the joke goes, the average size of a method is... the average number of methods in an interface is two-thirds of a method. In Go, I think that's the old joke, which makes sense because usually you have two methods, you compose them together, and now you've got three, and actually there's two-thirds it averages out as, yeah. I'll explain what that means. So let's go back to the Go. The two-thirds of a method thing, so let's say you have type foo interface, and it has foo in there. Let's keep this simple. A bara. And then we have a type foo bara. And then they're just embedding a foo and a bar in there, because you can do embedding. This is like the Plan 9 style embedding, which used to have in Plan 9C, which is great. Good extension. So this is the Go. Like, look, you have three methods, three interfaces, two methods. So the average of all of them is two-thirds of a method. That's the old joke, but it does actually seem to be the case. Like usually, building things together with interfaces, not keeping them separate. Combining constraints. Yep, in Odin we can combine constraints. I do not have a printable thing in there because we don't have traits, but the Odin's approach would be type is, let's say, numeric. Let's just say it's numeric, and you just put a comma in there. So the comma is saying this is got to be both of them. This is effective if I did and. So you could do and, but the difference is with the comma is they are separate constraints, and then you get better error message handling for it as well. Separate constraints and separate error handling. Like, oh, it doesn't meet on this particular constraint, because if you just did and your thing's really big, it would just say the entire thing's failed. It's like, well, where did it fail and which bits did it fail on? We don't know, because it could have failed on multiple bits. But having on the commas does aid in there. Very nice. Associative types. This is starting to get a little bit more complicated with their interface. They're also requiring types in there, and they're just being even more generic. This is what happens is like, okay, Odin that's the highest level you're going to get anymore. Like, you do have generics in Odin. I call them parametric polymorphism, or parapoly for short. But in general, programming language is made for humans, and once you start adding more fancy and fancy features, it gets harder and harder to use. But yeah, this is it's interesting to see where they're going with all this, and I'm about to stop now anyway. Oh yeah, they've got operator overloading as well. I've got to say this. Their operator overloading is done through their you implement it, which is a very good way of doing it, by the way. Actually, instead of having you implement, so it's similar to Rust, if I remember correctly. It was like Python. If you implement a specific interface which has for the overloading, you can then overload it, which is nice. And there's many things you can overload. Odin doesn't have operator overloading, but the main reason it doesn't have operator overloading is because Odin has built-in array programming, which may seem like, where? I'm like, I'll show you. Odin has built-in array programming. So, and also because it's got built-in array types, these are pretty much the two reasons why people want operator overloading most of the time in C++. They want it to implement behaviors to data structures which didn't have it before, which, like for instance, there's not a built-in string type or an array type or something like that. So you want to overload, create your own, and then overload it to do it correctly. The other one is to do mathematical stuff. So Odin's got like array types and string types built in, so that and map type, by the way, hash map. So that pretty much removes 99% of the need on that side. And then the other side is mathematics. And so Odin's like, right, what is the actual like subset that most people use? Let's just add it. And it's like, wait, what? It's like, no, bear with. So the first thing is arrays. We have two arrays here, A, B, and they're both F32s. Like this, yeah. We can do this if we wanted, or we could do that, or that. So this would be Hadamard product, the Hadamard product instead. So element-wise, these would just be element-wise addition, and it would work perfectly fine. And it works fine in Odin. And in fact, you can even multiply it by a scalar, and it would work, no problem. You can do either side, by the way. It doesn't matter. And then that's magic. That's absolutely fine, and that's one of the reasons. So one of my favorite features, which I don't even think they'll be able to do in their system unless they do something crazy, because this is just an array. We can not just we can focus it with the fields. Oh, we could even say .x, and we go wait, what? No. You know what we could do? We could do x.yz, get all of the parameters out, multiply it by b.zxy, like so. And then once we've got the multiplication of that, just get out the y(x) parameter. Yes, we have swizzling built into the language. This is such a useful feature for some shader languages. Why can't we have this at the systems level, application level? This is such a useful thing. And not just that, you can do RGB as well on it if you wanted. Only X, Y, Z and thing. And if you had it was 4 parameters, you could do RGBA or X, Y, Z, W if you wanted. No problems. And that just works. You can do that. There's no problems, and it will just generate the code as you expect, because shuffle or swizzle operations are in most architectures nowadays. So it does, and this can also exploit SIMD when it needs to. The other benefit you may think is well, what about complex types, quaternions? Well, we have them built in. We have a complex, and we're just going to say this is a 32. It has 64 bits in total, so it's 232 bits. Or we could have a quaternion, and we could say this is 128-bit quaternion if we wanted, and that'll work correctly and do all the stuff that you need to do. So you could do quaternion 1 times quaternion 2, and that would work as you expect, no problems. And we could get the absolute value of that, so the real value of it, no problem. It works. We also have matrices in the language. So we have matrix, let's have a matrix M, let's call matrix A. So we have a 4x3 matrix of F32, and a matrix B of a 3x2, and then we could do C, and I'm just going to write the type explicitly at the end here. 4 to F32, A times B, works magically. Done. So we allow for matrix types, we have complex and quaternions, as well as array programming in there. We have swizzling in here. We have pretty much covered, I would say, 99.5% of the need, even not 99.9% of most people need, especially for graphics developers and game developers, which is what many people who use C++ for anyway, by the way, needed. You don't need it. Like, it solves most problem. And also we have string types, obviously, so we have array types. So we have all the different array types. So we have fixed array. So I'm just going to do it at the bottom here, sorry. So for the other bits, for the data structures, we have a string type. No problem. We have array types, so we have that. We have slices. We have dynamic arrays built in with custom allocator support as well. These have custom allocators. This is one thing I don't think their language has already... Carbon doesn't even have yet. We have a map type, so we can have a key in there and a value. It's great. We have SOA data types of all the rest, as well as all of the other ones. So an SOA data type is a lovely thing. It means that it stores it out in structure of array format, built in. And this is... So we have pretty much most of the things built into the language that you need. You may think, oh, I still got a need for implementing X or Y. And I'm like, at that point, you may be obfuscating so much that it may not be easy to read anymore. And not just that, it's it's better to have the general good solution for most people than having a general solution, specific solutions for most people, rather than a general solution which doesn't really fit most people's need. So I come back from talking at this language, and shall I explain? And then they're talking about the memory and the safety. I've not really talked about the memory safety models, but they've got like a spatial temporal distinction between memory, and they're doing it with move semantics effectively. And the substructural type system, the affine type system they're doing, like Rust or C++11, and then doing other certain things on there. It's like, okay, so to go back to the Carbon language itself, what are my first impressions of this language? Well, I downloaded this, by the way. I'm not going to show it now because it will cock up on the stream and get even worse. But I tried to do the hello world in it. It took a minute to compile and run the hello world program. This is orders of magnitude worse than C++. Actually, two orders of magnitude worse than C++. How could you get it this bad? I mean, no, not even two, maybe even technically three, by the way. But how? Like, if your compile times are already longer than C++, and in fact, they might be even longer than Rust at this rate as well, you've already failed, in my opinion. You haven't learnt about why many people also hate C++. You need to improve C++. That means improve the compile times, that improves the type system, that improves so many other things. And it's not just syntax and minor inconveniences here and there. It's really a fundamentally uphaul of the thing, a language, and how you may even tackle things. So in my opinion, my first impressions about Carbon, in its current state, be very careful, it is doomed to failure. But that is because it is the first time it's come out, and clearly they're developing stuff at the time, and it's nice that this is great. I really love this Cambion explosion of new languages. It gives people loads of choice, and I hope for the best for Carbon. I really do. But at the moment, I don't think it's going to be that great. I think it's got many issues with it in terms of design, especially the semantics of it, not just the syntax. Syntax is easier to get fixed and all that, but semantics are really hard to do, and you have to get them really right at the same time. The other problem is they really are basing around LLVM. Now, I know most of the people who are working on it, especially like Janet Caruth, are LLVM lovers. But the problem is that now LLVM, like in Odin, we're now getting away from LLVM if we can, because it's so slow, it's so buggy as well. Every new version they bring out now it's every few months, because they're going to that release schedule. It has breaking changes, and sometimes it has regressions in stuff. It's just getting a pain to us, and there's no alternative if you want your own like custom optimizing backend, unless you do your own custom one, which is what we're going to have to be doing now for Odin, because we've kind of like, okay, we'll keep the LLVM backend, obviously, but we'll have another one in there we're implementing. In fact, multiple different backends. We'll have our own middle end system which generates the IR, so then we can lower it to anything we need, or if our own machine code, or if it's C, well, GNU-C technically, because it has to be GNU-C to make sure we have the features. We can't do vanilla C. Too much undefined behavior in vanilla C. And so many other things as we do. So thank you for listening, by the way. I hope this has been useful and informative. I hope for the best for the Carbon language, I really do, but I think in its current state, it's not really learnt from the past much, and it's only been focused on C++ and Rust and a spickling of Go in there. And I think there are other languages out there, such as Odin, again, such as Zig, such as, if you don't mind garbage collection, maybe Nim, but no, we'll say them. There are, and Jonathan Blow's language, JAI, or however you pronounce that thing yet. These are probably much better tailored for people in this domain who are wanting a new language. because a lot of people have just gone back to C nowadays, I know, because they're so fed up of C++. But then there's some people who want an alternative to C, like, look, we've gone back to C, and C is still not good enough for our needs, so that's why they're coming to Odin. That's why they're going to other languages now, because they really need something that's powerful. Again, another one of this is that they're not even, I don't even think they're even worrying about custom allocators or anything at this moment, or different memory allocation strategies, or different things like this, which is where a lot of performance comes in. They are really, even though that they are not, they've got the three different things like performance and debugging performance and safety, really, they are still trying to be safe. They're not trying to be performant, which are, I'm not saying they're at odds with each other, but there are different strategies when you want performance, which maybe would be classed as unsafe in languages such as Rust. So you have to be really kind of careful about what you're doing. I've now been rambling for 90 minutes. I hope this has been interesting. Please leave a comment in the below and make sure to like that smash button or whatever it's called. I just said that backwards. Oh God, I don't know what the YouTuber thing does. I haven't done this game in a while. But yeah, hopefully you've enjoyed this, and please leave me your comments and see if I've been unfair or I said something incorrectly at the time of recording. But yeah, and also make sure to check out the Odin programming language if you're very interested with it. Again, we're using this on Embergen, which is the Django Effects real-time volumetric fluid simulator for fire and smoke and explosions, and it's perfectly tailored for game and film, and it's a wonderful tool, and it's written in Odin, by the way, so that should give you that. Again, Odin has many principles you may like. That also has many batteries included, which many languages, now modern languages, do not present. We have SGL, OpenGL, Vulkan, WebGL, DirectX 3D, Metal. We have full Metal support native. It's not a wrapper. We have native Metal support. We are in the compiler effectively calling the Objective-C message stuff for you, but it's in Odin. We have MicroUI. We have so many other vendor libraries in there. If you look on it, we have a lot of them for you. And it's a very useful thing. And again, if you're very interested in Odin, I highly check out the Discord. There's always very active, always someone there to answer your questions, or even just if you just want to hang out and chat about random stuff in the Randomer channel, or show your pictures of food when you're in the pub channel, or whatever you want to be doing in there. You can just talk about random programming. It's a good, nice little community to have. And again, thank you for listening, and have a good day.